Okay, let's get started. Real dependency management. I'm Szczepan, core developer at Gradle, and why I'm doing this talk, I've been adding in a couple of recent releases some interesting features for dependency resolution, including the dependency resolve rules, which are hooks into the dependency resolution process. And I'll be demoing them today, among other things. My session will be use case driven mostly, so we'll be discussing some of the interesting use cases for dependency management, especially conflicts. This is the most interesting stuff. And let's see how it goes. And I'm from Krakow, Poland. Nice place, you must visit at some point. Okay, so anyone remembers the jar hell? It was nice. In 2002, roughly, remember how we did the dependency management? Applications were built with and, if they were lucky. If not, who knows with what. If someone wants to use Hibernate, let's say. But okay, now, someone wants to stick stuff into the database and get it back, right? Okay, let's use Hibernate. So here's the Hibernate, one jar, but it requires 25 other jars. So he just sticks those jars into a folder within the application, and all those jars were consumed during the compilation. Before the compilation, Ant was doing that, and we had this one big folder with all the libraries. Some people who cared more for the project, they moved those jars around various folders to have some sense and structure, to know which jars are needed for what other jar, and this sort of worked, right? I mean, sort of. We had various problems with that. I mean, for example, we didn't know after a year of working in such project, we didn't know whether certain jar is still needed or not, because things has changed, libraries, Hibernate went away, somebody wanted to use iBatis, let's say. Some of the jars from Hibernate still left in that directory, so nobody really knew. There was like a black box, like 150 jars, application works with them, let's keep things a thumbs up and let's move on. So the modern dependency management and the transitive dependencies, that was a lovely invention. I really love that. I mean, all the modern dependency management, for me, the most important thing is this transitive dependency concept. So I only care that I need Hibernate, right? What Hibernate needs is something I would really not want to be bothered with. Normally, we have to care about those transitive dependencies because they lead to conflict and they lead to runtime errors, right? But the idea that I just can tell, I want to use Hibernate and everything just works is beautiful. So, whereas in the previous approach, right, with the jar hell, with all the jars in one directory, we didn't have problem with conflict. Because if conflict was resolved when you moved those jars to this directory, you see, oh, I already have Apache Commons there, right? So the jars are different. I think at that time, there was no yet convention that you put a version in the jar. Sometimes jar was just, common/jar, that's it. So basically you made a judgment call. I'm going to use this jar. Application works? Works. Cool. Let's move on, right? Let's ship it. So the conflict management and the conflict resolution was very early, and if application worked, we are happy with those jars. Now, when we have a proper dependency management, modern one with transitive dependencies, with metadata that describes every dependency, metadata like POM.xml, like IVXML, we have repositories that we can retrieve dependencies from. Now the conflicts are becoming interesting because they can happen at some point. Like you all use dependency. Like anyone who uses Gradle, like everyone. Who uses Maven? Okay, cool. Who uses Ant and Ivy? Okay, who uses something else, something exotic? Whoa, what's that? Make. Nice. How does the dependency management look with Make? Yeah, use those jars from that directory, something like that. Excellent. All right, so in modern dependency management, right, you would be surprised how many conflicts you have, but by default, Ivy just uses latest version, Gradle uses latest version, Maven uses some version, usually. Maven has very interesting dependency resolution, a default conflict resolution mechanism, which is, we call it nearest. So basically, whatever is, so if you have multiple candidates, multiple different versions of given dependency in one class path, and during the dependency resolution, Maven figures that out. Oh, there are multiple candidates. Which candidate wins in Maven? Right? The one that is closest to the root, right? The root of the resolution process. So, like if you have a first level dependency that says version 1.5, that version wins. And there was a time, long time ago, when I thought that this style of the default conflict resolution, the style that Maven introduced, is very cool, because your first level dependency is something you consciously declared. This is the version I want to use, and Maven respects that and assumes that if there are other candidates coming through, I'm going to use the one that is declared by someone here. So it kind of makes sense, but then when I learned more about the dependency management and I got more experience in that field, it doesn't make sense anymore to me. The problem with that is that the version can be downgraded, which is a big problem. So assuming that all the libraries in the entire world are using the semantic versioning scheme and they are always backwards compatible, I know that's not true, but let's for a second assume that we live in that world, then Maven's resolution would not really help us at all, because of the fact that the version can be downgraded. That the version that your first level dependency wins, and this can downgrade certain version that other library needs, right? Some library of your choice uses Commons Lang 2.0, you are using Commons Lang 1.5, Maven chooses 1.5, boom, at runtime, for example, you might have an error. Gradle and Ivy will by default use the latest version, which assumes that there are no that the library that is resolved keeps the backwards compatibility, and that's, I guess, reasonable assumption to make. Obviously, if this assumption is wrong, and then you're going to have problem and you're going to have to fix it. But at least it feels to me that this is a reasonable default behavior. Any questions? Any objections? No? No? Oh, Justin, after the conference, okay? All right, yeah. So one other important thing about modern dependency management is that it needs to offer some ways to tweak the resolution process. For example, to resolve this conflict manually if the conflict resolved by default and the version selected by default is not good. And Maven does provide that, for example, through the dependency management section in your parent POM, for example. Same like Ivy and Gradle, we do support that in various ways, and I'll be demoing those ways. But just keep in mind that this is totally important. Like on the consumer side of the dependency resolution process, the side that parses the metadata of dependencies and grabs them all, downloads them, there has to be a way to tweak that process. There are like libraries that have incorrect metadata released. There are many of those, right? So we have to, for that reason, we have to be able to tune that on the consumer level. Not to mention that the conflicts those conflicts are also solved by the APIs. Okay. So diagnosing conflicts in Gradle. So let's move on to some demos and to Gradle, how we deal with the conflicts. So I do have three applications: car, grocery, and shopping. And the idea is that I'm taking the car, go to grocery to buy something, right? So shopping uses the car and the grocery. So let's take a look at the car application, the build.gradle file. It has a couple of plugins applied: Java, IDEA, Maven. I'm not sure if I'm going to use IDEA plugin for IntelliJ, but I'm going to use definitely Java and Maven. I need to specify group and version because I'm going to be publishing this library, and I have some dependency. I depend on Google Collections. I know I shouldn't, but that was a good example. I'll explain more later. And I'm using Maven because currently at Gradle, the dead simplest possible way to exchange artifacts between projects that are completely separate would be the Maven local library, Maven local repository. It's like a well-known repository. Everyone knows what it is. So I'm applying Maven plugin. I can write Gradle install, library gets installed to the local Maven repository, and I could use it from other projects. That's the easiest. Obviously, there are multiple other ways to do it in Gradle. I could I could allocate some kind of a directory in my file system and use the IV format and basically publish as IV, but that would require a few more lines of code in my scripts, and I don't want to have that, so I'm using Maven. But don't worry, we are not using Maven behind the hood, yeah? So, because people are asking me that, oh, you're applying Maven plugin, you surely use Maven, right, behind the hood. No. We use some Maven libraries, some Maven APIs, but Maven is not used. Okay, we are using the conventions Maven has laid out, right? Where the local repository lives. Okay, so we have this, and I believe that I can do. Let's cd to the car. Let's go Gradle install. So install is a task that gets created for you when you upload. Oh God, please no. No, when the demo is. Okay, let's take a look at the source code of the car Java. We have a, okay, map maker not available. So let's do something like that. Doesn't matter, really. I think that should do it. I think right now it's not really important what the class does, so long it compiles and installs. There you go. And I think we should see something in the Maven repository, which would be probably org Gradle webinar. Yes, the webinar. This is the name of the group, I believe. Oh, it's org cars. Sorry, it's org cars. And then we have a car. Oh, something has been installed first. API car info as well. So let's prove that this is really working. I'm going to first remove it from the local repository. So it's all gone. Now I'm going to install again. I'm going to ls my local repository. There you go. Version 1.0 got released. There I have a jar, I have a POM. POM describes the dependencies and other things. But in general, I managed to install that locally. Let's do the same for the grocery application. Let me go quickly to the builder Gradle to show you. It's using also Google Collections. Wow, with a different version. Interesting, okay? And now let's install that, hopefully this time without any problems. There you go. Let's ls, actually not the car, or I think, grocery was it? Shops. Yeah, inconsistent, right? So we have a grocery here, and we have 0.1 alpha. That's the version I've chosen. Doesn't really matter right now, but okay. Now we have a shopping application. Let's go there. It's using cars and grocery to do stuff. Okay. We're gonna have conflict because I'm using different version of Google Collections in cars and grocery. So let's first see it. So the two reports, Gradle dependencies and Gradle dependencies inside. Those are your friends if you want to diagnose things regarding the conflicts and versions of your dependencies. Later on, I'll show you some demos how to use the API that those reports are using. So all the information that will be shown when I run those reports is retrieved from Gradle using a public API, which means that all the information you see from those reports is something you could hook up into programmatically using a nice public API. So let's do it. Let's do Gradle dependencies first. There you go. It's showing you some stuff, and we can see that through the shops, we are picking up transitive dependency Google Collections 0.9, and cars are pulling 0.8, which gets the 0.9 is the version that is used. One interesting thing we've added in the recent versions of Gradle is that you can specify the configuration. Because by default, the dependencies tasks choose all configurations. You might not need that. So let's show it only for the compiled configuration. There you go, conflict. So if you want to find out more about the conflict, you can do dependencies inside task. Dependency inside task, which basically zooms into a particular dependency. So if you want to, this is useful for like large dependency trees. to like insight, to get an insight why this dependency is selected, why this version is selected. So I'm not sure if I can demo it neatly for that simple case, but let's see. Dependency, let's say Google. It's fine. It's and then let's do configuration compile. So it's zooming into any dependency that has a Google in the coordinates. So it's picking up the Google collections, and you can see that there are two versions used. Oh, well, there's only one version used, but there are two versions, two candidate versions during the resolution process, and the one that has been selected is selected due to the config resolution. And this is, you have access to this information through the public API. I'll demo that later. But there you go, config resolution by default. So let's, any questions you might have for that?
I have a question.
Yeah, sure.
What if I specify different version number for different configurations? Like one version, I want to compile with this version, but I want to run with slightly bigger.
So what's happening is that so runtime configuration extends compiler configuration. So whatever version you have of that, let's say Google Collections, you have version 0.8 at, not sure, okay, this feels like an unreasonable use case, but let's consider it. Compile configuration uses Google Collections 0.8. Runtime configuration uses Google Collections 0.9. Okay, and then what happens? Okay, during compilation, 0.8 is used. During runtime, 0.9 is used because there's a config resolution, and default config resolution picks up the latest version. Latest is 0.9, 0.9 wins. Make sense? Yes. So it's like, by default, we pick only one jar to the class path. We don't want to allow different versions of the same jar on the class path. Obviously, that is very likely it leads to this situation, multiple jars of various versions. Sorry, same jar, different versions on the same class path, trouble. This equals trouble. Okay, so let's get back. Let's do some manual config resolution, and the ways of doing that. Actually, before that, you can turn off the automatic config resolution in Gradle. You do it this way. So configuration, compile, resolution strategy. Let's do it this way so you can see nicely. Fail on version config. This means that configs are not allowed. Basically, you're turning off the config resolution. I'm going to remove the compile configuration because by default, dependency inside prints from the compile configuration if the Java plugin is applied, so I don't need that. If I do it now, we have a conflict. There's 0.9 version and 0.8, and there's a conflict. So it's this configuration, the compile configuration, is not resolvable at this stage. Yep.
Kind of related to the question that he had. Is there a way to have, like, I only want this during compile time, like for building OSGI bundles? When you compile, you might need some external resources, but when you runtime, those are other bundles that export those resources. Does runtime always? That would be
difficult, I guess. That would be difficult because the current model, which I'm not very happy with, is that runtime configuration extends compile, which means it gets all that stuff that compile puts. So this is doable, but it will be slightly tricky. So you probably would have to use the dependency resolve rules. I'll demo that later, but you would probably add a dependency resolve rule to the runtime configuration which changes something, right? It's, I think this is how I'm not sure. I would have to drill a little bit this use case to give you like a best answer, but it's doable, but it's not going to be like that, I think. Okay. So we have a conflict. Now let's resolve this conflict manually. So you can see the ways of solving those conflicts in Gradle. I think that's my next slide. Yes, resolving the conflicts manually. Okay, so what I can do is let's leave this fail on version conflict for now. It doesn't hurt, and let's add some stuff that will resolve the conflict. So what I can do is I can add a dependency, com Google Collections, Google Collections, and then with version, let's say 0.1. Let's rock. 1.0, excellent. Let's do Gradle dependencies. Is it going to work? No. Good answer. I haven't yet resolved the conflicts. Now I have even 3 candidates. See, the Google Collection 1.0 is one of the candidates for the conflict resolution. So I can do something like that. Actually, I'm going to drive from the user guide. So a Gradle dependency handler force. So dependency handler is the object that you use within the dependencies script block. This is all documented in the user guide, but that's why I was searching for dependency handler. This is the thing that you configure when you open the dependency section. Let's take a look and let's see some examples with forcing. There you go. I have an example of Hibernate 3.1. Dependencies, Hibernate 3.1, I'm going to force it, which means that if by any chance this dependency participates in a conflict resolution because transitive dependencies pulled up a different version, this puppy wins. Yeah, 3.1. I'm going to do the same. Okay, so here what I'm going to do is I'm going to do this. I need to put it in the brackets because of Groovy, but all good. And then here I want to do force equals true. Gradle dependencies. I think this should work. There you go. Let's do configuration compile. There you go. So we can see that 1.0 has been selected. So this is one way of dealing with that. Kind of a Maven-ish way. What do you think about that approach? You like it? Yeah? What's the problem with that?
What if there are multiple forces?
Okay. Good question. I think the latest will win.
Oh.
Or it's going to fail. Please don't let me test that. Either it's going to fail, the resolution will fail. I don't know what to do. You force 2 versions. Are you crazy? What's going on with you? Or it's going to pick up the latest. Yeah. So this is not good. We don't like the solution. My fundamental problem with that is that this does not describe the truth. We don't depend on the Google Collections. We depend on shops and cars. Google Collections is an implementation detail of those guys, right? We should not be forced to specify this dependency here. No. I mean, not in that fashion, because this implies that this is a compile dependency, which means that I have code that I need to compile code against Google Collections, which is not true. I just need grocery in the car. We don't like that. But for the record, now that is a way. I mean, that could make sense if we have Google Collections as a dependency of that project, right? Then I guess this way could be used to resolve the conflict manually. Any questions you might have? Nope. Okay, easy stuff. Let's get back here. The next one is an exclusion. So what I could do is exclude the offending versions. So I'm going to remove that one. And if I run Gradle dependencies, it should now fail because we have failed version conflict, 3 versions. Okay. And again, I can go back to documentation. There's a way to exclude any transitive dependency that gets pulled from this Hibernate dependency. So it doesn't matter, on which level of this tree this dependency is found. It's going to be excluded from resolving this subtree. And I could do something like that. So I could do something like that. It's gonna be some copy paste or encapsulate and reuse. Exclude group. Let's exclude all the Google Collections group. Yeah. if you do exclusion, I guess the preferred way would be to exclude by group and module. It's more correct, let's say, because we want to exclude this specific dependency, and it's a protection for us just in case there are other dependencies that have the same group. But normally, I mean, you're free to choose what criteria you use for exclusion something. And then I'm going to copy paste that here. Encapsulate and reuse, sorry. Okay. Doesn't matter. Let's run it now, and I hope it's going to pass. There you go. 1.0 is used. The 0.8 and 0.9 version does not participate at all in the conflict resolution. It has been excluded. Not sure I like this solution. One thing is there's duplication here, which we don't like. Well, we could remove this duplication in an interesting way. For example, what I could do. So I'm going to remove that stuff and do configurations. All. That should do too. So in every configuration, I'm excluding Google Collections. Yeah. That will.
Even the one you added?
Come again?
Even the one you added?
Even the one I added, yes. Excellent. Excellent choice. And demo looks good, it's just stuff does not compile, yeah? Yes. So this is the way to go. If you don't like certain dependency here, you can exclude it here. No, really you should delete it from here. But let's assume that we don't use that one. Yeah. And I've seen in real life that's a fairly reasonable approach. That's what we do. It's not ideal because, for example, time goes on, right? And at some point in future you might not have that conflict because all versions are good, but you are still excluding this thing, which might not be ideal. But this is useful for other case, which I'll come back later, which is when you have library conflict, Google Collections not liking very much Guava. Well, we'll get to that. Now, what I want to stop at a little bit is that we use all method here and passing the closure. It is critical that if you do stuff like that, if you configure things on all configurations, use this all method, because there's a fundamental difference between configurations all and configurations each. Yeah? So each is a standard Groovy method, and basically you're going to iterate through all the configurations, which may work most of the cases. But all is our method that we added to all our containers, and basically it means that we are excluding for all existing configurations, but also for any future configurations that will be added. And that's really important because this way, using this all block, you are protected from the ordering issues that, this plugin is applied in different order than the other and those kind of things. So just keep in mind, that's why I'm using all. It's just way, way safer. So this basically, it means that all configurations will receive this action. Okay, and then existing configurations immediately this action is executed against all the existing configurations, but it will also be remembered. And then when you create a new configuration at some point later, or you apply a plugin that creates configurations, this action is also applied.
So by excluding it, how does that really help you, though? You still have the conflict.
That's correct. Yes. Thank you for pointing that out. I guess I went a little bit too far. We're going to use that for something else, for library conflicts. Yes. Thank you for pointing that out.
And that could be used, like, it's real tough to get the right JUnit, handpress, and Mockito combination. So you can exclude, like, handpress all, because you know handpress chorus.
Yes. But you're completely right, so ignore that. Forget what I just saw you. Let's show you 5 minutes. We're going to get to that. Okay. Right, so we have that config. Hang on, let me see what's next. Force modules. Okay, let's go back to our case where we have 3 candidate versions. Thank you, configurations all, for confusing us all. And then let's get back here. Let's see if I have still conflicts. There you go. We have some conflicts. And I'm going to use force module. So what I'm going to do I'm going to reuse the resolution strategy block I have here. So there's actually, let's drive from the user guide. Grail force module. There we go, resolution strategy, some examples, fail on version conflict, and also force. Right? So let's do force, and let's do 1.0. Okay. Let's see the dependencies now. Version 1.0 is selected, so we have resolved this conflict manually. Let's do dependency inside actually, because it will show us. Inside. It will show us that it's been forced. So you see that the resolution, the selection reason has changed. Previously, when I showed you there was conflict resolution, now it's forced because we have forced it. And this is quite interesting way of solving the conflict. It's pretty clear that we are forcing that, pretty explicit. That's why I like it. In many cases, that would be my preferred way to manually resolve conflicts. Obviously, to use this force mechanism, you don't need to be in the fail on version conflict mode. Yeah, the forcing mechanism is something that can also work with the default conflict resolution when for all dependencies you want to use latest versions, but you want to force some of them. So this will still work. So if I do dependency inside, it's still forced, and yeah. So it's still used. Any questions you might have for that? Yep.
If you compiled like one of the other ones that had 0.8 or 0.9 and you had that force, would that still force it to 1.0 or is that only on conflict?
It still forces it. So force is, I guess, force is unrelated to the conflict resolution. It's just informing that we prefer this version pretty much. Yeah. And whether you use default conflict resolution, taking the latest version or not, the forcing still works. Yeah. Sure.
Does the force actually introduce a dependency, or if there's actually no call for that particular library, it will do nothing at all?
Oh, excellent question. So basically, if you don't have Google Collection dependency at all, but you are forcing it, it's doing nothing. Which is, I don't know if I like it, to be honest.
Maybe a warning, but otherwise.
Warning, because it's like if it's not needed, why are you forcing that, right? So it's almost like a build failure, saying hey, you're forcing something, but why? Why? It's not needed anywhere.
I think the worst thing would be for it to just introduce it for no reason.
Yeah.
It's just not doing that.
So that's a very good point. So remember, the first conflict resolution method I showed you was introducing like a fake dependency and then force it. This is much better because it does not introduce a dependency, right? Which is basically what this is how you want to describe the problem, right? Okay, I know that there's a conflict resolution, but I need to force that version, and that's it. If it's transitive dependency, okay. Another question? Yeah, sure.
So one of the complexities we see a lot is that we have a lot of configurations, and depending on which plugin you apply or plugins, you will have different configurations available. So is there some way now when you have compiled at runtime, those are always or pretty much always there.
Mm-hmm.
When you have a lot of custom configurations, is there some way to say, do it for most of them, or can I figure out?
Yeah.
I really love some way to figure out which configurations does Google Collections is it in right now?
Yeah. So so I guess we don't have that. Okay, so if your use case is that, okay, so this project uses Google Collections in some of the configurations. I don't know which one, but
Yeah.
it's on. Find me, please go to tell me in which configuration Google Collections live. I guess we don't have a report for that. This is something you could do using the APIs that the dependency reports are driving. You could have a task. Actually, let's demo that later. Oh, that's a pretty interesting demo. Let me just make it.
The dependency inside, if you pass the configuration name, that defeats the purpose for dependency inside. Because if you're asking me to pass the configuration name, I already know the dependency, kind of. So the whole point of using dependency inside is to figure out, hey, tell me.
Yeah. It's like, yeah, possibly. So like, we're looking for your feedback on the forums then. I mean, possibly, I mean, we thought that it makes sense to limit the dependency inside to specific configuration, but maybe that was not like a best decision, yeah? Maybe it should search in all the configurations.
So the question is, when you create the dependency graph, is it per configuration or is it for the entire project? Because if it's for the entire project, then there's no point.
The dependency trees, the resolve dependency tree, always per configuration, always.
Oh, okay. So
There's no such, there's I guess no concept like dependencies per project. It's like always per configuration. So, yeah.
Yeah, I think something or some task that says given a dependency.
Find me this dependency, right? Like where is it used, or if it's used at all. Yeah, I mean let's when I get to this API, let's please remind me, and I'll write really quickly a task that does that, so that you can see how this API can be used. But there you go, it's forcing modules, and that's a nice way of solving a conflict in a manual way, if you need to do it. And then dependency resolve rule, I guess the most advanced way, because it's a really programmatic hook into the dependency resolution process, so let's use it to force that version. Okay, so here what I'm going to do, it's each dependency. Let's actually go to the user, to the DSL reference. As you can see, you have some examples. There's an each dependency example, and for each dependency that gets resolved within that tree, there's a dependency resolve details object passed in that you can use to influence the resolution process. So, okay. Just tweaking the window. So the details object, and then I know the details object, so I don't have to look up in Java what are its fields, but yeah, but feel free to do so. So details group requested, which is the requested object, group equals, let's encapsulate and reuse a little bit. Oh, I'm late. Let's add a name as well. Okay, and details requested name equals Google Collections. If that criteria is met for the given dependency, what I'm going to do is I'm going to do details use version 1.0. Unless I have a typo, this should work. Come on, Gradle, don't fail me now. Oh, it's too slow. Something is wrong. Yeah, something is wrong. Is it? Oh boy. Hang on. Let me just make it if each dependency. Okay, cool. Let's use all the details. This is met and this is met. It's looking good. Come on, Gradle. Be nice. Okay, let's kill it. And let's do it again with -I and see what's going on there. Oh, there you go. You didn't see that before. Okay, so 1.0 version has been selected. Let's run it without -I, so that we're just gonna see that. And then you can see that the selection reason is different. It's selected by rule. It's a pretty heavyweight way of solving that problem. I wouldn't use that, but I wanted you to see that dependency resolve rules can be used for that fashion. And we're going to find some other interesting use cases for dependency resolve rules soon enough. But you can see also with here the direction of Gradle. Basically what we want to do, we not only want to provide a decent dependency resolution engine, but also we want to provide you hooks, like a lower level hooks for solving interesting cases. Because you can hide that away in your plugin and do something interesting, and you're going to see soon that I can do something even more interesting with dependency resolve rules. Any questions? Nope. Okay, cool. Let's move on. So library conflicts, right? So it's slightly different. Some jars don't go together, and conflict resolution does not detect it. Because conflict resolution, the standard conflict resolution dependency management is geared towards a coordinate, the group and name, right? So if something has the same group and the same name is considered the same thing, so we should resolve the version conflict if the versions are different, right? However, there are occasions where two libraries are incompatible, right? They can't be used together on the same class path or the same because they throw runtime errors and stuff. But it's not truly a version conflict, right? It's like a library conflict. And we have to resolve that manually in that case because, I mean, conflict resolution will not find it out. And some examples of that is Guava and Google Collections. So now we are slowly getting into Guava because you shouldn't use the Google Collections. I just use it for my demos. And because we had an interesting case recently where having Guava and Google Collections on the same class path leads to runtime errors that are hard to debug. And solution for that is just to let all library owners know, please upgrade your Google Collections to Guava. Maybe they hear me and they'll do it tomorrow, we'll see. But in real life, when your dependency tree is complicated, there can be a situation that one of your transitive dependencies is pulling the Guava, some of the other of your transitive dependencies is pulling Google Collections, and you have those, both of them on single class path, and there might be some runtime errors. And when I was on the plane here, I really wanted to reproduce that exactly. There's no such method error. I was trying different versions of Guava and Google Collections and using different APIs, and I failed. But it's like when you want something to demo, you're never able to reproduce it. But then in real life, bam! It's like it's failing, and people are trying to find out the solution, and it's never simple with those kind of errors. It's like when you have this no such method error, you are copying this message, you are putting it to Google, you're searching and praying that going to be some answers, right? Or Stack Overflow link to Guava and Google Collections problem. But if you don't find it, well, good luck. A few hours later, you might find out what's the problem. So let's have that case here, and let's figure out how to solve that. So I'm going to make the car use Guava. And then here we're going to use the Guava, let's see, 12. It doesn't matter. I need to install a new version of car. Well, it's not going to be a new version. I'm just going to replace the existing snapshot version that is in the repository. And then I'm going to go to shopping. And I'm going to go for dependencies. Do Gradle dependencies configuration compile. Okay, let's see what's going on here. All right, now we have Guava, we have Google Collections. Let's drop the top level Google Collections because it's not needed for our example. It's just confusing a little bit. I'm going to drop that one and redo the dependencies. And something like that can happen easily in the projects. Like two different dependencies are pulling out Guava and Google Collections, and this can be a problem. How to solve that? Oops, sorry. It's only my wife, no worries. Okay. Exclusions and dependency resolve rules. So exclusion is very simple. Let's get it over with. So for example, I can exclude from grocery, exclude module, Google Collections. So right now when I print the reports, oops, do I have a typo or something? Google Collections, exclude, oh yeah, not module by group. Okay, there you go. Who saw that error? Oh, nice, yeah. Okay, cool. So we've excluded that. So it's a reasonable way to solve that problem, I guess. I've seen that, like in Maven, that would be a standard way. That's how I'll do it. I would set up the exclusion somewhere in the parent POM.
Now that's only excluding it from resolution of the dependencies it's still going to use the libraries. When it compiles, obviously it has to.
Google Collections is excluded from the resolution of the subtree.
Right.
The subtree of grocery, which means it's not on the class path, on the compiled class path. It's
So
excluded.
it won't be on the class path at all
At all.
when the grocery thing starts to compile?
Well, no. We are now within the shopping application. Yeah, we are not within the grocery
Oh, okay.
application.
So it's just for itself, okay.
For the so grocery on its own, yeah, when we cd into the grocery directory, we don't have a conflict there. We just
Right.
release it. Yeah, the conflict appears in the shopping, which is consuming both car and grocery.
Right.
And he's consuming them both, and hence he's in trouble because Guava is there and Google
Right.
Collections is there, and there you go.
Now, if he doesn't really use Google Collections at all himself,
Yeah.
then he's fine. But if he does, then
Yeah, then he can't. He will have to
choose one or the other.
choose Guava because that's exactly what Google guys want us to do, right? Use Guava instead of Google Collections.
Yeah.
Forget about Google Collections. Long time, 5 years ago, deprecated or so. So that's standard way of it.
Yeah.
Okay, let's use the dependency resolve rule to solve that. And let's forget about exclusion, though it's a fairly okay way to solve that problem. And then let's go to dependency resolve rules, all right? So if, let's say we have Google Collections, I'm gonna use the use target method, not use version. I'm gonna replace it with Guava. Or Google Guava. Let's say 13. Let's say 13. Well, is it everything okay with that?
Need target.
Yeah, thank you. I'm just testing you. There you go. Okay,
Difference between target and
excellent. So use version allows you to only replace version. Now use target, you replace completely the dependency. So it's no longer, I'm replacing Google Collections with Guava. So it's like a completely different dependency now. Yeah, I could replace it with, Hello World Dummy 5.0 if I want to. I'm not sure if the program will still compile, but I can. So yeah, it's pretty interesting. I mean, moreover, we're gonna add more interesting stuff to dependency resolve rules, right? So that's why we have this details object. Right now, the details object has requested version, has two ways of mutating the dependency: use target and use version. But in future, it can have more stuff, more interesting stuff to resolve. And there's like a whole bunch of things we could do. A whole bunch, I'll tell you. So now, let's see what the Gradle dependencies show.
So when you say their use target, is that you're just putting in a string, you're just putting in an IV coordinate. So it doesn't go, that doesn't have to be in the model, right? Because at this one, like 13.0 was not in the model anywhere.
You can also use the version that is just not in the graph at all, just
Right.
brand new one, yeah.
So so you just say anything there. Basically, use target, just find
Yes.
it. It's a find and replace.
So yeah, I mean it's a good point. I think what you are after is that you would like to choose from the graph, right? That's
yeah,
what you're
I would
after.
like to choose. Right. In this case, we'd like to pick the one that's in cars, right?
Yeah.
Or we got cars. We'd like to pick that one.
Yeah. So that's another things we could add to this dependency resolve rule, so that you can have more, you can make more educated decision, right? Because this is like you have to know that Guava is replaced with, that Google Collections are replaced with Guava. However, what I really would like to tell Gradle is that, hey Gradle, Google Collections and Guava are the same thing.
Yeah.
That's it. This is the only thing I want to tell Gradle. And Gradle should figure out, oh, they are the same thing, so they should not be on the class path together. So I'm gonna choose one of them. And hey, well, I need to tell also Gradle that Guava is a newer version of Google Collections. So I will have to tell that. And the Gradle, oh, Guava is the newer version. So I'm gonna ignore versions. I'm gonna just use Guava, unless there are multiple versions of Guava. So I'm gonna use the latest version of Guava from the candidates. But yeah, I mean, that's basically the direction we want to go. So we will add APIs, like lower level APIs to the dependency resolve rules and maybe other kinds of actions.
Yeah.
And we will add, on top of that, we will add some layer to, to make it more user friendly. So the typical use cases you would solve not by, scripting the dependency resolve rules, but by just invoking some top-level API, saying like instead of like Guava is more important than Google Collections, and you know they are the same thing. Okay, so that's yep.
But yeah, so I just spent a couple hours this morning looking at there's 3 different Apache HTTP clients, basically, and it's the same problem like with the 3 different IB coordinates for the same.
You mean they are like different in terms of names and groups, right?
Yes.
Okay.
There's like Commons. The group used to be Commons HTTP client, then it went Org Apache HTTP client, then it went Org Apache HTTP.
Because the libraries should not be allowed to change their group names and names. And if that was the case, you wouldn't have to even implement that. You know, all would have worked.
But it seems pretty common with open source.
Yeah, I mean, if the library changes like something like group or name, it's always problematic.
Yeah.
It's going to always hit the like a developer somewhere there in some country just wanting to finish off this with the error.
But if you have some rules that basically say these are the same thing, or
Yeah.
you know, pick this whenever you see this.
But don't limit just one-to-one. You'll get these people who bundle an old Spring and it becomes like 6 libraries.
Yeah.
You know, like you stick to one-to-one, that's barely going to cover it.
Yeah. So I mean, this is the challenge now. So we solved the jar hell in some way, right? But the challenge is now with the quality of metadata, with the fact that libraries have different names or have contained some inlined other jar contents from other jars inlined inside. So, and then the modern dependency management should offer you some ways to hook up into the resolution process and fix those problems.
So now, for the library, how do you handle manifest class paths? So like, good config, if I have a jar which has manifest class paths, like, how would that work? Because assuming Gradle allows us to have dependencies on local file system jars.
Yes.
And one of those jars.
Oh, okay. So I'm not sure if I understand your question well, but you are saying how does it work if you have a just local dependency, just some file dropped in the directory, and it's put into the configuration, and how does it participate in the config resolution?
No.
No? Okay, cool.
So the other question is the local file has a manifest class file. So there are multiple jars specified in the manifest of the jar.
So, okay, you're talking about the manifest that lives inside the jar.
Yes.
Okay.
It has, so typically you specify multiple jars in your manifest class file and you give that
Okay.
developer, and you just use that and
So Gradle does not use that information for the purposes of dependency resolution. I don't think it's in plans to do so. It's like you can put anything in this manifest. Like it's like that would be like a. Well, I wouldn't. So I don't want to like argue here because I guess I haven't even discussed that ever. This idea. But generally, we should pick a model that we want to follow. And the model we are following is that if your library is released to a Maven repository, we're going to use the information from the POM XML. That's it. And then also, if the library is released to an Ivy repository, we're going to use the information from Ivy XML. So we can't use also the manifest from jar because what if there are conflicts, which one to use, those kind of things. But at some point in Gradle, maybe the dependency management will be so robust and flexible that you can hook up some actions inside so that you could do something like that maybe. Okay, so we have selected the Guava version 13 and Google Collections. You can see that this arrow here, that the Google Collections is the version that was requested, but Guava 13 was actually used, and it will be used on the class path. Let's run the inside task because that might be interesting. So it's selected by rule and conflict resolution. So I attempted to make it readable. Hopefully it makes sense. So it's selected by rule because we've added a rule that forced certain version, and then it's conflict resolution because we had 12 version and 13 versions. So conflict resolution has selected 13. So, tell me what's going to happen if I do this. If I do version 11 here. What's going to be the version that is selected? 12, yes. So, if you use the depends resolve rule, it does not mean that you are like that conflict resolution it still applies. Okay, makes sense?
It's interesting because so it's not saying, oh wait, did you do that?
Oh, hang on, yeah, you're right. So I'm using the Guava 11 and I guess the report could mention Guava 11 as somewhere because we have like 3. I guess that could be slightly better, I think, because we are missing from the report that Guava 11 also plays some role here. But I'm not sure. I yet don't see where it should fit, because that's the version selected by conflict resolution. Those Google collections have been replaced by Guava 12.
You'd almost want Google Collections 9, Arrow, Guava 11, Arrow,
yes,
Guava 12.
Yeah.
And
but,
that would.
Yeah. But I guess we might hit the limits of those console reports. Because like it's how much stuff and metadata we can stick here. I mean, at some point we'll have a fancy HTML report if some contributor eager to do so will arrive. And you could, I don't know, you open this HTML report and you click through and you see all the conflicts, you see all the versions, all those things. And we will probably not overdo those console reports. I'm pretty sure that this information that Guava 11 is also used can be retrieved with this lower level API that those reports are using. But don't let me test that. It's going to blush if it's not the case. Okay. Okay, so we've done this exercise. So dependency resolve rules used for resolving a library conflict. Okay. Another interesting case, avoiding the bad versions. So let's assume. Okay, let's make grocery also use Guava. Okay. And let's say it's using the Google Guava. It's going to use version 14. Let's install. Let's go to shopping application. For now, let's leave that as is. Okay. Let's see Gradle dependencies. What's going on now? So we have, okay, let's remove the rule for now because it's confusing. Whoa. Whoa. Oh, okay. Let's remove all of that stuff. It's a pretty clean file. We have some conflict, different Guava versions used by those two applications, and we have a situation like, and let's assume that version 14 is not good for some reason. It has a bug. And we want to have a clean way of informing Gradle. Hey, Gradle, if you encounter version 14, please use version 14.01. And that's it. That's the only thing we want to say. Go back here. So what I'm going to do is I'm going to undo this removal, and if we have com Google Guava, and the name is Guava, and details, let's actually make it simpler. So I'm going to remove the details object, just some groovy tricks. I'm going to remove the details here, so it's slightly simpler. Requested group name and version equals 14.0, and we're gonna use the use version method 14.01. I think, is it like that? We'll soon find out. Not sure if that version exists. No, it probably doesn't. Let's search for it. Ooh. Okay, I think it's like that then. No, come on, don't fail me now. Okay, let's go. Oh yeah, Guava. Let's see, Guava. Yeah, 14.0.1. So it should be available. Congo Guava 14.0.1. It's failing for me for some reason.
Do you need to remove the details object from
So it should not. Oh yeah. Thank you very much. Yes. Too many changes at the same time. We should do a small little change and then test. Okay. So why I removed the details object? I think that's gonna work. Cheers. So in Gradle, all of our APIs that receive a closure, by default, it's a kind of groovy term. By default, put the object that is get passed in as a first delegate of this closure, which means that you can directly call methods on the thing that gets passed in. So keep in mind that if you see code like that in Gradle, it's because we add some code to switch the delegate of the closure so that the scripts look nicer. But you can't replace that with, if you have standard groovy methods, like for example each, right? Then this wouldn't work. So sometimes you would have to do this it requested group, because it is a standard, like a convention for the parameter that gets passed into the groovy closure. Hopefully it makes sense, and for the Java users. But generally we have something like that. And let's run it. Hey, excellent. So now version 14.0.1 is used. And this is a pretty cool way of solving that problem, because take a look what happens. I only say to Gradle that we won't only replace version 14. This is the bad version. The good, blessed version is 14.0.1. If we use version 14, our servers on production explode. Okay. So if I go back to, let's say, grocery, and then change that to 13, and then install, and then go back, and then run dependencies, you can see that this rule that we applied does not apply because we don't use version 14. So it's pretty cool because we don't force the version 14.0.1. Okay, if it's not used, that version, that's fine. Let's use 13. Let's use 12. But only the 14 version is bad, and that's the only version we will replace. And that might happen. I mean, this is an interesting use case. That might happen that you want to avoid certain version, right? And then you want to specify a different version that should be used instead. And those kind of. And it also does not mean that you have to script in every single place and every single project in your organization those kind of dependency rules. You could have a plugin that adds a standard dependency resolve rules that don't have standard, let's say, blessed dependencies and dependencies that should be avoided. So those things can be neatly hidden and your build scripts remain pure. Any questions you might have? All good. So let's take a look at some other cases. All right. Oh, another interesting case, and now we are going to use a different API, is validation of those dependencies. So let's say we don't want to replace version 14, but we want to fail the build and say to the user, hey, please don't use version 14, and just do something so that version 14 is not used. That's also possible. But since I've changed the versions to be 12 and 13, let's assume that the version 13 is now bad version. So, okay, I'm gonna quit. I'm gonna remove the resolution strategy for now. What I'm gonna do is I'm gonna create a task, validate dependencies, and then in this task I'm gonna do last. And then what I'm going to do is I'm going to iterate through the dependencies of compile configuration, the resolve dependencies. So configurations, compile, incoming, resolution, result. So this is the access to the new model of the resolve dependency tree. You go through configurations, compile, and there's this incoming section. And it's why it's called incoming, because at the moment in Gradle, a configuration object contains two kinds of dependencies. Dependencies that let's call them real dependencies of your project, but also it contains the outgoing artifacts that you publish to the world. At some point in Gradle, we'll probably separate those concepts, but currently, since that's the way it goes, it is this incoming object that allows you to refer to the incoming dependencies of that configuration, and there is a resolution result object. Obviously, this is documented, so you can take a look at the Gradle resolution result. Not the first entry. Somewhere there. I much prefer if the first answer of Google is same. Yeah. Okay, so we have resolution result. Let's see what we can retrieve from this resolution result. Actually, let's see the Java book. Gradle resolution result API. There you go. So we have things like all dependencies, all module versions, so you can iterate and you can drill down the tree of dependencies. I'm surprised that it's not a part of DSL reference. Let me just check. Resolution result. Oh, it isn't. Okay, cool. We can do each module version. So the graph of dependencies that is available via the resolution result contains edges and nodes, and in our nomenclature, nodes of that graph we call modules, and edges of the graph we call dependency results. So it might not be so intuitive when you start working with the resolution result API, but you'll get your hand over it shortly, and you'll be able to navigate the dependency graph. So don't worry if the names that I'm using are not like easy to grasp. So each module version. So if it, let's take a look at the module version. Gonna go back here. So we're gonna, oh, okay, so I made a mistake. So it's actually all module versions, not each module version. All module versions. 2 typos in the one word. Nice, Stepan. All module versions. And the object that gets passed is resolved module version result, which has an ID and the selection reason. So ID is the thing that got resolved, so the final version that is used. So if the ID group equals Google collections Guava, of course, and then Guava, and then version 13. Let's say you are not stopping me. And then it ID name equals Guava, and it ID group version equals 13.0. So if we find it, let's say we're gonna create a list of bad dependencies, bad versions it's called. And then let's stick it here. Bad versions equals it ID. And then at the end, what we could do is we're gonna do if bad versions empty. If it's not empty, we're gonna throw some exception. Throw new Gradle exception. You are using some bad versions. You, the developer. Fine. And then let's say bad versions. Bad versions. Okay. And then we need to call this task to perform this validation. So it's called validate dependencies how I can shortcut it using VD. No such property bad versions. That's how it ends up when you develop in Notepad. Yeah.
So you're in the wrong scope with the
You're not in the last. Here we go. So, it should work. Oh. What's the mistake?
Like you're on scope.
Bad versions. So we have an if statement. Oh, okay. Got it. Got it. There you go. There you go. Oh, beautiful. Oh, bad luck. Let's try again. Okay. Actually, let's do something proper. So Gradle idea. Let's generate the. It's not going to work now because it doesn't compile. So if the script does not compile, you can't do much with Gradle, let's say. Okay, so we have idea now. Now we're going to use the proper ID. Excellent for development. Shopping, build a Gradle. There you go. Versions, configurations, if versions empty. Oops. In my professional view, this should work. How often I said that? Let's see what's there now. Yeah, cool, works. Magic. You just need to import to IntelliJ and all problems are gone. So we are using some bad versions. That's how you could add some validation, some interesting validation. You have access to the entire dependency graph, which means that you can find out what are the reasons, and we're gonna do something interesting.
So is that a Polish word?
No, Polish word would have 0 vowels, and you developer. Okay, you bad developer. You see my English. This variety of words is my. That's how you describe me. Okay, cool. So that's one interesting way you could do. We could validate that, and then the user can fix that problem in some fashion. Maybe he should go to the team that is releasing a library that has that uses Guava 13 and say, "Hey guys, please don't use that version of Guava because it's bad. Please release a new version with a better version," and then my build can pass. Or he can use the means of resolving that problem to tweak, force the version that is required. So there you go. Any questions you might have to that? Sure.
Now, some repository managers have the ability to store extra metadata for the modules and artifacts. Is there a way at this level in the API to look at that metadata while maybe you want to look at maybe you can store that in the repository about rules about, hey, don't use me, use this guy instead.
Using Ivy, so
yeah,
some extra attributes and stuff. So we maybe it's hard to say. So we don't want to we don't want to put all the features of Ivy in Gradle. Yeah.
Right.
So it's like a tough question whether I think it's reasonable if you could query for more information and extract more information from the resolved dependency graph.
Right. And it doesn't have to be like Ivy, in fact, because like Artifactory has ways of attaching properties to things after the fact, which is really perfect for this sort of thing. It's not an immutable thing that happened to build time, but later you discovered that Guava 14 had above it. How do you store that in a way that all children can see?
So at the moment, this API won't provide you such information, such extra metadata, and it does not even provide, like at the moment, this model, this resolution result, for example, it does not have artifacts, right? Which is also a limitation of this model. This model has been driven by the needs of the dependency report tasks, and those tasks didn't need their artifacts, for example. But it's useful to know, the artifacts that got resolved with that module, because they have, for example, classifiers, which might be an interesting information. This API will definitely grow, and it will definitely include more information. I'm not sure if it will include all the stuff that Ivy has in the Ivy.
With just the module descriptor, be it a POM or an Ivy, You got it right there, the result.
Yeah, it's possible. Yeah.
Yeah. Or maybe a way to hook in at a different lower level point so that you can ask Artifactory, for example, while you grab this module, grab the properties. I might want them later. You don't want to have to do round tripping later.
Yeah.
But if you're already talking to it.
Yes. So I mean, you actually touched on an interesting. Okay. Yeah. That's possible. I mean, one thing you have to know is that when the resolution result is available, we have resolved the entire tree. Yeah? So it's different from the dependency resolve rules in a way that dependency resolve rules are triggered when the graph is being resolved. It's like during the process, so in between downloading various dependencies. However, this thing is available at, when the resolution is done, when we resolve all the dependencies. So basically, if you are accessing resolution result, that will trigger dependency resolution for the particular configuration. So that just want to mention on the side, not that it really matters what you say.
Probably with the strategy, right, at that point.
Yeah. So I mean, this model will grow. We'll have we're gonna receive more use cases like from Netflix guys, for example, and then we will grow it. So that's one of the visions here. So let's take a look what's my plan next. So that's what we've done. Oh, that's an interesting case. So you want to list all the conflicted versions from the given dependency tree. Yeah, that's possible with this model. So let's do that. So what I'm going to do is I want to list a conflicted library and all the versions that are all the candidates that are considered for the conflict resolution. So what I'm going to do is I'm going to do if it selection reason. So this is all like in our Java doc. So we have a selection reason, which has methods like its conflict resolution, for example. So selection, and we don't need it, as I mentioned earlier. So selection reason, conflict resolution. So if the particular module, if the conflict resolution was, if it was involved in conflict resolution, let's print it. So let's do conflicted modules. Let's make it a map. And then conflicted modules ID. And then the dependency, the resolved module version result also have dependencies and dependents, which means those are the incoming edges of the dependency tree and outgoing edges of the dependency tree. So let's include the hang on, which one we want? Dependents, yes. Dependents, that's what we want. So, and also we want to do dependents. So all the dependents that we are interested in requested. That'll be like that. I think something like that. Surely it's not going to work the first time I run it. Okay. Why am I editing in the text path? Come on, guys, you should tell me that I'm using IntelliJ and it solves all the problem. Okay, so if conflict resolution, then we're gonna include the conflicted modules, all the requested versions, and then let's print it.
Can you include the font?
Sure. Sorry, I should have thought about it earlier. What's the easiest way of doing that? Huh? There should be some.
Can you zoom with the mouse pad?
I'm trying
No,
with various
like a map.
Oh, pinching, excellent, thank you very much. So print line conflicted modules.
I think you want that outside of
What's up?
move it out to the next scope.
Oh, thank you, thank you, thank you. Thank you very much. Okay, and then let's go conflicted modules, each key value. Let's do some groovy magic here. A print line, key, and then versions, something like that. And then something validate, so print conflicts. Let's see how it goes. Gradle print conflicts. Wow, it worked from the beginning. And we could, let's make it slightly better. So we're gonna do the version. So we only show version. There you go. So it's looking, let's prove that it actually works, right? Let's add some dependency that is not conflicted. This is my favorite one for demoing. No, not that part. Let's do who knows that library? I don't know. Shouldn't be in the compile class path, should it? No. Yeah. So I've added new dependency to show you that we are actually finding those conflicted, not all of them. So if only the Guava is conflicted, those are the versions that are used. So what is interesting here is that I'm able to derive this information, why certain module is selected, whether it's conflict resolution, whether it's other reason, and then I could select it and do something interesting. Do you have any questions for that? What was that use case we discussed at the beginning of the session? Someone, Jens, you had an interesting idea.
Oh, to grab the version from.
Oh, to look for the particular dependency in all the configurations, yeah?
Yeah, find the find the configuration.
So let's do that, because that's interesting. So let's say we're gonna put that one here. Don't use Mockito, use JMon. No, just kidding. Okay, so we have, let's say we're gonna be searching for Mockito. So find dependency. It's gonna be kind of heavyweight task because it'll go through all the configurations, right? I'm gonna do each now for the configurations because we are in the do last sections, which means that we are in the execution phase. And for me, it feels more natural to just iterate through the configurations that we have rather than use the all method that has slightly different semantics. So configuration.
What's the difference in semantics?
No, so what's the difference?
Yeah.
It wouldn't make a difference here, right? But it's the difference in semantic is that all you are basically firing the action for every existing configuration, and you are recording an action for all the configurations that will be added later. And I hope that no configuration is added later at execution phase, because that would be weird if that was the case. But you never know. Maybe there is a case for that. And some task at execution is adding a configuration, and then this action will kick in. And for example, if this action does the validation and going to phase the build, something weird might happen. So I mean, yeah, I would use each, but maybe I don't have strong arguments here. Okay. Does it answer your question?
Yeah.
Okay, cool. So configurations, each configuration, and then let's do conf incoming resolution result. All module versions, and then if the module version ID group equals org Mockito, then let's say found your favorite in configuration. So this is not very nice because it just does the print line, but And then we could do, let's say, project get property dep.
So there's no like contains closure or anything like that on the.
No, you would have to script it as a.
Yeah.
Yeah, I mean, we didn't have a case, I guess, strong case for that for such a report so far. But let's try if the thing that I've coded actually works. So I'm going to do Gradle find dependency minus p dep group equals org mosquito. Nothing. I made a mistake. So get property dep group. That's what I did. Dep group, yes, and. Let's make it simple for now. And let's complicate that later. Oh, it's org mosquito, is it? Mosquito. We can pass on the it's still not showing anything. Configuration H count decommutarization ID group Mockito. We do have a Mockito dependency or Mockito.
Version ID comes
should you have it or it?
Oh, you have ID.
I do have an ID which should work. All module versions ID group. Well, let's do this. Print line ID. There you go. Debug statements during the session. I love them. What we have now? Guava, com.org. Do you see Mockito here? No?
On the compile, so it's just
It's not iterated. I don't see it. It's not included for some reason. I'm going through the configurations, all test compile. Let's do Gradle dependencies. Oh, because it's failed. Ha! It's failed. Why it's failed? Or Mockito core 1.9. We don't have. Oh, got it. The OSGI convention 3. Yeah, we need to change the naming scheme to have 2 dots so that OSGI is happy. There you go, OSGI. You broke my demo today. This should work now. Excellent. So interesting thing is that the module versions that we've been iterating are the resolved things. Yeah. So the module versions are all the resolved things. If you are looking for unresolved things, you should go for all dependency results, because when the dependency is resolved, you have a node in the graph, right? But if it's unresolved, you don't have a node. You just have an edge that leads to nothing. That's our model of the dependency tree. So now, if it's resolved, I think this should work. So we should find it. Yay, found your favorite dependency, test compile, test runtime. Then we could do this project, get property, dep group. Yeah, let's change it here. But I like it with the dot, so let's do it like that. So this should have the same result. Come on, yeah, thank you. And let's do JUnit. Was it org JUnit or JUnit? JUnit. So we're looking for JUnit. JUnit again, it's found in the compiler, test compiler. So yeah, it worked at the end. I guess with that, I'm gonna finish the session. Anyone has some more questions, maybe? I guess not. So please enjoy the dependency management with Gradle, and don't report too many bugs. But you can report how many you want. Yeah. Thank you very much, guys.